stack representation using array. The primary prerequisite for understanding this video in a better way is that you should know basic concept of stack and you should know the basic concept of array, because I'm going to discuss the C programming code for representing stack using array. So just to recall what exactly is a stack. Stack is a kind of a linear data structure and it is used for performing the operation through one end only. You can see here that there is only one end for performing the operation. You can see the structure here. So whatever the operations you are going to push something into stack or you're going to pop out something from stack, that is being performed from one end only, and that end in stack it is called as a top of the stack. So there are three terminology that you should understand. One is what is top, second is what is push, and third is what is pop. So we can say that top is a current element in the stack. Push is a operation of performing adding elements into the stack, and popping out means you are deleting the existing element present in the stack. So the simple idea is that we are going to see the operations with the help of C programming code here, right? So basically, as we have discussed that it's a kind of linear data structure, we will just focus what are the different applications that are possible with stack. The most technical operation that is being performed with the help of a stack is recursion. Recursion, where you are going to call a function within the same function body, that is called as the recursion. Then many examples are there which actually needs only one end for performing the operations. Like you can consider your mobile call log history. Whatever the recent call is there, that is always being present at the top of your call log history. So that call may be missed call, received call, whatever it may be, but it is always on the top of the that particular call log history. You can take one more example, browser history. Whenever browser is being used to serve the web pages, the web page that you have recently served, that is being displayed on the top of the browser history. So what I mean to say that there are many applications which requires only one end for performing the operations over there. Now, whenever we are talking about a stack, then we should know that how by how many ways you can represent a stack. So you can represent stack by two ways. Either you can use stack using array, or you can use linked list for representing stack. Any data structure, I'm repeating, any data structure that may be linear, that may be non-linear, can be represented either with the help of array or with the help of linked list. These are the two basic data structures which are used for representing any, because stack is a kind of abstract data type. Any entity has to be represented for implementation part with the help of either array or with the help of linked list. So in this video, I'm going to specifically focus on stack using array. So you can see here that there are two ends which are being there is only one end and two operations we can perform with it, push and pop, like that. Then the next concept is how we can write down the C code for performing the operations with the particular stack. So you can see here, suppose I am representing a stack here. I will just remove this one and I will try to draw a diagram for stack. This is just a simple rough sketch I am trying to draw for showing stack, right? And you can see that it is having only one end for performing the operation. The other end is closed here. The other end is closed. Whatever, if I want to insert something or if I want to delete something from the stack, then I have to refer only one end. And just before some time, we have discussed that that particular end is called as top of the stack. So suppose I insert a element as 15. I'm going to put this 15 into my stack. The question that comes in mind is that where top is being pointed out. When I'm inserting this 15, where the top is being pointed out. So you can see that I'm going to use array. I'm going to use array for representing a stack. Array, it's again a linear data structure, and we know that array, it has some index position, it has some elements, and like that. Array, it works on index position, and the first index position that comes in any kind of array, that may be one dimensional array, two-dimensional array, multi-dimensional array, it is zero. Any array, it starts with zeroth index position. So I can say that whenever I am inserting 15, where my top should point, my top, it should point at this element. So currently, if someone asks me where the top is being pointed out, where the top is being pointed out, so you can see here that top is being pointed at 15, but the value of top is not 15. 15 is the element that is present in the stack. The index position that you are going to use here, that index position is top, and you can see the value of top. The value of top, it will be 0. So when I have inserted the first element 15 into my stack, my top is being pointing out to the element 15, but the value of top is 0. And the very important statement that I am going to write it here now, that when we are representing when we are representing stack using array, top is always index position in array. Index position of, very important, current element in array, right? So you need to understand here that whenever we are representing stack using array, whenever we are trying to write down the programming code for stack using array, top, it is always the index position of the current element. And you can see here that 15 is the value that you have inserted into the stack. So what actually I did here, I have inserted 15, I have pushed, I have pushed 15 value into my stack, and now this 15, it will be the element present at stack of top, but top, it will be index position, so top, it will be 0. We will try to insert one more value. Suppose I have inserted the value 20 here. What will happen here? Here it will be suppose 20. As soon as I have inserted 20 here, this top, it is no more pointing to 15. This top, it will be shifted here, and now it will be incremented by 1 because the index position has been changed. So it will be top equals to 1. Right. So whenever you are inserting the element into your stack, when you're inserting a value element, when you are performing the push operation into your stack, then your top is always being incremented by 1, and some values, whatever the elements you are going to push, that will be reflected there. We'll try to insert one more value. Suppose I want to insert 35 here. So where I can put 35, the 35, it will be here, and you can see here that your top is again being changed. Your top, it will be here now, and this top, it will be incremented by 1. Top, it will be 2 now, right? So the thing is that you can insert the elements, but you are representing stack using array. And at the starting only, I told you that whatever the advantages, disadvantages of array are there, that are same applicable to stack, because though you are creating stack, you are not actually creating stack. You are performing the operation in array only. You are performing the operations only in array, and that particular operations are being performed in last in first out manner. So you can see here that array, it as a fixed size. Suppose, just I told you, we are not creating stack. we are creating array here. So you can see here, suppose I have declared a array whose name is stack, and I have given the value as stack 5. So you can see with the help of this declaration, you can see the name of my array is stack, and the size I am talking about, the size is 5 here. It means I can insert 5 elements here. Now see, we will try to insert one more element here. Suppose I insert 70 here and we keep this 70 here. What will happen? This top, it will be again incremented by 1. You can see here the top, it will become 3. You please observe, you are going to increment the value of top by 1. Right. Then suppose you are going to insert one more element here. Suppose I have inserted the element as 85. We will try to insert. Suppose I'm going to insert 85. I will keep 85 here, and now the top, it will again changing. Top, it will become 4. So if I'm talking about the array whose name is stack and there are 5 elements, how many elements I can insert in this array? Of course, I can insert only 5 elements. Considering the index position starting from 0, the 5 elements, it will be respectively at index position 0, at index position 1, at index position 2, 3, 4. So when your top is 4, when your top is 4 and you are talking about the array size 5, your stack will become full. And now if I want to insert this 90 cannot be inserted into the stack. And the simple reason is that your top is already at 4 and your stack is being reported as full. So drawback of array is that array is static. Whenever we are dealing with array, whenever we are dealing with array, we have to take care that whatever the size is given, you cannot exceed the size. I cannot exceed 5. If I am talking about the array of 5 elements, I can insert 5 elements only. If I am taking less elements than 5, of course it will be memory wastage, because I'm blocking permanent memory which is required for these 5 elements. So if I'm considering that integer, it takes 4 bytes, it is actually giving me 20 bytes of memory. 5 into 4, it will be 20 bytes of memory. So I cannot exceed 5, and if I'm going I'm going beyond 5, then it is not possible. Right, so try to understand the simple concept that whenever the top is being reached at 4, I have to stop because stack is being full. So there are, whenever we are performing push operation, there are two terms that we need to understand. The very first term is that you should understand, that full and overflow. One is full and second is overflow. What is the difference between these two words? Basically, when you are writing a program, from a programming point of view, actually both of these conditions are same. When top is 4 in an array of 5 elements, of course stack, it will be reported as full or it is reported as overflow. But the difference is when your top is at 4, when your top is at 4, then your stack is being reported as full. And now when I know that my stack is full and still I'm trying to put this 90 element into my stack, which is not being inserted here. So that particular condition is called as overflow. So performing push operation, please listen to me carefully. Performing push operation on full stack is overflow. And full means what? Your top is at 4, your stack is full. And still, if you know that your stack is full and you are trying to push something over there, then it is called as overflow. So basically, first the thing that you should know here, what are the basic operations that I have performed with this particular stack. I am talking about push only. So if someone asks me ki, what is top? Here top is 4. But what is the value which is being stored at this particular stack, that is 85. So I'm writing two statements here, that top is 4 and stack of top is 85. try to understand the difference between these two terms. Top is index position, and what is stack of top? Stack of top is the value which is stored in that particular at that particular index position, right? So stack top is 4, and what is stack of top? Stack of top is 85 here. So if my array name I have given it is as stack, stack of top, it will be always pointing out to the current element into the stack. And top it will be the index position into that particular stack. Right. So if I'm right, I will try to write down the code now for performing the operation into the stack. So I will just rub this and I will try to write down the code. So if I'm writing a code, I will just focus on push function here. So if I'm writing void push here, and whenever we are writing the code here, we should understand that when at what extent your stack is being full. So if I'm considering that I have declared a array of 5 elements, then if top double equals to 4, it should simply print a message that stack is full. It means as your stack is full, you cannot perform more operation with it. Else, this control, it will go in else part only when the stack is not full. Maybe top is at 0, maybe top is at 1, maybe top is at 2, top is at 3, but definitely it is not at 4. There are some scope to insert the value into the stack. There is some scope to push a value into the stack, right? So first I need to understand that which value I want to insert. So for that I have to take a variable. So I am considering that I have declared an integer variable x. So I will input that value from the user first. So we'll just give message, enter value, and with the help of simple scanf statement, we will insert that value x into the stack. We have taken the value of x, like when we have tried to insert 85, you can consider that 85 is the x here. So I'm making two operations, two statements. I'm performing two statements in my program when I'm going to push the value into the stack. The first is top is incremented by 1. Try to understand. When your top it was 0, only 15 was there. Then when you have inserted 20, your top is incremented by 1. When you have inserted 35, your top is incremented by 1. When you have inserted 70, your top is incremented by 1. And at last, when you have inserted 85, you have your top is incremented by 1. So top is incremented by 1, and this is not only sufficient, you have to tell the compiler keep this new value. Maybe that new value it was 15 for first attempt, then 20, then 35, then 70, then 85, that this new value is your new stack of the top. So what you need to do here, you have to write down that stack of top is that the new value. Which is that new value? You have already inputted that value into your program with the help of x. So you have to write it down, stack of top equals to x. Here I'm ending else part, and here I'm ending this push function. So this is a simple code. This is very simple code for understanding the operation of push. Again, I will repeat here that two things you should understand for this program. First thing, you should know what exactly is a top. When you are writing stack using array program, top it will be always index the position of current element into your stack. So you can see here top is currently 4, but index position and the value stored on that index position, both the things are different. So if I'm keeping the name of my array as stack of top, it will be always the current element, actual value. You can see here that actual value is 85 here. So if you understand the difference between these two, top and stack of top, you will understand the code easily. Now we will perform the operation of deletion, that is the operation of pop. So I will just remove this code and we will rub this one for understanding the concept of a stack again. Right. So for performing pop operation, you should know that where when your stack is being empty. Because if my stack is empty, how I'm going to perform the operation here? Now I will just again draw a simple what we can say diagram here, and currently my stack is empty. You can see that there are no values. Simple question is, if there are no values, where the top it should be pointing out. Because when I will insert a new element, suppose 15, I will again insert this 15. So when I kept 15 into my stack, my top it was at 0, right? My top it was at 0. It means when top is 0, please listen to me. When top is 0, your stack is having only one element. But if I remove this element from my stack, of course top it will not be at 0. Then where the top it will be? The top it will come down. It will be coming down. So it will be at 0 minus 1, and at 0 minus 1 it is minus 1 only. So when top is at minus 1, you have to understand your stack is being empty. So this particular condition you are being to use in while performing the pop operation, right? So I will just remove it and we will again try to understand it by inserting some values. So I'm going to delete it and I am going to rub it again. So this is again a simple stack and I will insert some random values here. I am inserting 15 and you can see I have kept 15 here, and I have inserted one more value here. Suppose that value is 89 or 69. 69 is the second value that I'm going to keep it here. One more value we will insert, suppose it is 70, and we will keep 70 here. So as you can see that I have inserted these three values into my stack, and you can see that this is my 0th index position, this is my first index position, and this is my second index position. And of course where the top is being pointing out, which is the current element, the top is at 2. So your top it is being present here. So top is 2 but stack of top is 70, right? So what will happen if I want to delete, if I want to remove this element? If I will remove this element, what will happen? Top will come down. So where the top it will be now? The top it will be at 1, right? Because you have deleted that element. So what I did, I actually decremented the value of top by 1. Again the same thing, if I remove this 69, again top it will be decremented by 1. So where the top is being pointed out, the top it will be at a 0th index position like this. And when I will delete this last value being present, of course where the top will be, the top it will not be at top equals to 0, it will be at minus 1. So what will be the value of top it will be minus 1. So what I mean to say, when you are performing the pop operation, you need to take care where your top is being pointed out, right? So the simple thing is that we will try to write down the code for pop function. So this will be void pop, and then first we will check whether our stack is empty or not. So if top double equals to minus 1, you can print a message that your stack is empty. Your stack is empty. And then and then in else part, you have to write down the code what should be the condition if the stack is not empty. So if the stack is not empty, then you have to first choose the element which you want to delete. See, you can decrement the top. Like when I have deleted 70, you have decremented the top. When you have deleted 69, then you have to if it is 69, then you have to decrement the top by 1. But first you have to tell the compiler that which value you want to delete. How the compiler will understand that you want to delete 70, or you want to delete 69, or you want to delete 15? If you want to delete 70, then you have to specifically tell, because it is not always 70. You can insert any random values over there. So you have to mention that whichever the value being present at stack of top, that you are going to delete. So you have to store that stack of top into some variable. So I'm writing here, if I'm considering that variable as x, so it will be x equals to stack of top. And then now you will decrement the top minus 1. This is else part close, and this is pop function close. So if you observe, in pop function, in push function, we have written stack of top equals to x. So what is the difference between stack of top equals to x and x equals to stack of top? With the statement stack of top equals to x, you are making new element as stack of top that you did in push. But when you are writing x equals to stack of top, means you are choosing the element which is being already present at stack of top. See, I can delete only those elements into my stack which are being present. And as stack is having only one element, I have only one choice. I have to delete the element which is being present at stack of top. If you see this particular stack diagram 15, 69, 17, I cannot directly delete 15. If I want to remove 15, then I have to remove first 70, from then 69, and then 15. Why? Because that operation I am going to perform through one end only. So I can reach to 15 only when I'm going to remove 70 or 69, like that, right? And these two steps, x equals to stack of top and top equals top minus 1, you need to understand for pop. And for push function, it will be stack of top equals to x and top equals to top plus 1. But in push function, you need to take care your stack, it should not be overflow, because overflow it will happen when your stack capacity is at max size. You cannot insert the more element into it. And underflow it will happen when your stack is empty, when your top is at minus 1, and still you are trying to pop out the element from it. So full, overflow, empty, underflow. These four type of terms you should know. From programming point of view, full and overflow are same, empty and underflow are same. Even I can print here stack is underflow, because I'm not going to able to perform the operation here. So top double equals to minus 1. If top is at already minus 1, then your stack is empty. And then whatever the condition you have taken here for push, you have to take it for full or overflow condition. Right, so this was all about stack data structure. I have not elaborated stack data structure here. I have tried to explain specifically the conditions which are required when we are representing stack using array. A display function will be again simple here. If I want to display element, I will discuss that code also. So we will just remove it, and we will try to take the stack again. So suppose I have taken the stack here, and we are already considering that there are three elements. Of course, this top it will not be at 0. Top will be at here, so it will be top will be at 2. It is at 0, 1, 2, and like that. And now if I want to uh, go for display function, then I will just write down the code for display, and I will check whether the stack is empty or not, because I have to write down this condition for display also. So I will just print the message that stack is empty. As stack is empty, you are not able to display the elements over there. And then for else part, you have to write down the code simply by using a loop, like you use a loop for array. So as we have already considered that stack is name of my array, So I will take for here for I equals to 0. But now I cannot write down I equals to, like, suppose my array as we have already considered as int a stack of 5, right? You cannot say that for I equals to 0, I less than equals to 4, that is max size. No, because it is not necessary that top it will be always at 4. Top can be at 0, top can be at 1, top can be at 2, top can be at 3, or top it can be at 4. So you have to write down from 0 to top, it will be I plus plus, right? Or you can also write in a reverse way. You can start with the top at the from the current position, and then till value of I is greater than 0, you are decrementing the value of I, like that. So any one of this loop you can use for displaying that value, and simply you are displaying the contents of array like this. So it will be stack of I. This is end of else and this is end of display. Right, so this will be a simple code that you have to refer it for display. So that's all. In this video, we have tried to see how we can represent stack using array. In next video, we will be discussing about stack using linked list. Thank you.